Okay, in this tutorial I'm going to go over some more complicated examples of covalent bonding, and essentially we're going to look at what we call double and triple bonds. So guys, essentially covalent bonding is when we get nonmetals. Nonmetals are trying to get a full outer shell, but they don't have enough to give away. We've got two nonmetals pairing together, so if you don't have enough electrons, what was the solution? Basically to share some, to bond covalently. That means sharing electrons. So if you still don't have enough electrons by sharing, what's the solution? Just share even more. So by sharing even more, usually these nonmetals can somehow gain a full outer shell. So if we have a look at this, a double bond is a chemical bond in which 4 electrons are shared as opposed to the usual 2. Let's look at an example. So oxygen. Oxygen has an electron arrangement 2 and 6, and I'm going to use Lewis diagrams because they're a little bit cleaner and tidier, and we're really only interested in the electrons in the outermost shell anyway. So oxygen, if we draw oxygen, its Lewis diagram, it's just an O, and it's got 6 valence electrons. So 1, 2, 3, 4, and maybe I'll make it on top, 5 and 6. Okay, if I take another oxygen, so I'll do that one in a different color. If I take another oxygen and pair it up the side here, we can see, well, we add 1 electron there, 2, 3, 4, 5, 6. Well, we've got a bit of a problem. We've got oxygens sharing in the middle here, but they still only have 7 outer electrons. They're still not going to be happy. They're still not going to have a full outer shell, and so that's going to be a bit of an issue. So how can we do that? We can't just add in 2 electrons. Each oxygen atom has 6 electrons. It can't just materialize an extra one out of nowhere. Otherwise, why would they bother bonding in the first place if they can just add electrons if they need it? So in this case, they've each got 6. They can share those, but they have to make do with those ones. However, we can't just leave them with 7 valence electrons. Those atoms are definitely not going to be happy with just 7 valence electrons. But what we can do is share another pair. So take these 2 unpaired ones and share them in the middle as well. So if I take this one on the end, if I get rid of that, and I share it in the middle, and for the blue one here, if I get rid of that one, and if I share that in the middle too, okay, oxygen, now they each will have 8 valence electrons. So another way of drawing that, sometimes we draw them a little bit more like this. Okay, so we could draw oxygen, again with its 6 valence electrons. And the other oxygen here, I can do them as crosses, with its 6. So we've already got 2 being shared in the middle here, and basically what we can do is we can take these bottom ones and throw them in the pot as well. Alright, so if we've got them here, we can put those in the middle. So we've gotten rid of those ones. And essentially there again, that's your double bond. So it's just showing the 4 electrons shared in the middle, that's a double bond. 2 lots of 2 pairs being shared in the middle, and the other one's just staying in the original position. Each oxygen now has 8 valence electrons. They're going to be happy. Okay, so let's clear that. Let's have a look at another example. Alright, triple bonds, so getting even more complicated. Triple bond, again, it's if that's still not enough to get a full outer shell, just share even more. So a chemical bond, triple bond is a chemical bond in which 6 electrons are shared as opposed to the usual 2. So the example here is ethine, which actually goes by another name, acetylene. You may have heard of an oxyacetylene blowtorch. So acetylene, often used as a fuel there, produces very high temperatures when burnt. So anyway, if we want to draw this, CH, what we need to do, let's start with the carbons. So most molecules like that are a short carbon chain. So draw in the carbons. Carbon is number 6, so it's got 2 and then 4. It's got 4 valence electrons. Okay, and it's got a hydrogen attached to it, so I'll put that over on this side. Hydrogen. So that's happy, it's sharing electrons, there's no issue there. Okay, drawing another carbon. So we can already draw it in, sharing one pair over here. Okay, and then its other 3 electrons. So that carbon's got 4 of its own. And it too is bonding with a hydrogen. So we can put a little hydrogen there. So the hydrogens are happy. They've got a full outer shell, even though it's only 2. For hydrogen, that's a full outer shell. But the carbons definitely aren't happy. This carbon's got sharing 2 in the middle, 2 on that side, but it's got unpaired ones at the top. So if we get rid of the unpaired ones at the top, we can share those in the middle. So that one goes there, this one goes here. Okay, so now we've got 4 on this side and 2, but still only 1 down the bottom. So this one's still unpaired. It's only got 7 electrons. So again, if we haven't quite got enough yet, we just share even more. So getting rid of those ones. And now those ones join in the middle too. And you can see there's my triple bond. Those 3 pairs of electrons being shared, 2 being shared on that side. So this carbon here has got 6 plus 2 on that side. It's got 8 electrons in its outer shell. It's going to be happy. So that's it. Alright, basically guys, we're just going to look at a couple more examples. So moving on, here we've got ethene, CH2, and carbon dioxide. Let's have a quick look at those. So the first one, following a similar idea, let's draw our carbon. Carbon tends to have 4, or carbon does have 4 valence electrons. Okay, that last electron is a bit wonky. So carbon has 4 valence electrons. The hydrogen over here has 1, so it can share over there. We can put another hydrogen, so each carbon's got 2 hydrogens attached. We can put another one there. So that's the first bit, that's the CH2. So we've got this first bit, CH2, a C with 2 H's. Now we add another C. Alright, so this C we can put the electron there. So we're sharing a pair in the middle here, and this carbon has got its other ones, of course. Okay, and it's got 2 hydrogens attached as well. So I'm going to put a hydrogen there, and a hydrogen there. But the carbons still aren't happy. Yes, they've got 2 in the middle, 2 on that side, 2 on that side. But the top, there's still some singles, so it's only got 7. So again, if we don't have enough by sharing, just share even more. So those 2 become shared in the middle here, and you can see now each carbon's got 4, 6, 8. The carbons are now happy, so that's how you do that one. Carbon dioxide. Okay, so again, start with carbon in the middle with its 4 valence electrons. Alright, and then we're going to draw in our oxygens, so I might do those in red. So oxygen is element number 8, so it's got 2 and then 6 valence, 6 outer shell electrons. So let's try and draw those in. 1, 2, 3, 4. Okay, 5, 6. So we see oxygen's still not quite happy. 1 unpaired one there. Let's chuck the oxygen on the other side here. So 1, 2, 3, 4, 5, 6. Okay, and you can see again, no one's quite happy here yet. Carbon's got an unpaired set of electrons at the top and the bottom. Even if we put those together, it would still only have 6 total electrons, so that's definitely not going to work. Oxygen's got 7 at the moment, so that still doesn't kind of work. So the solution again, guys, if you don't have enough, just share even more. So if oxygen lets this one go into the middle, So if that oxygen lets that one go into the middle, but in return, the carbon has to also contribute, okay, the same. So if the carbon lets that one go into the middle there, okay, on the other side, if the oxygen lets that electron go into the middle, put it down the bottom there, into the shared pot, and if this carbon lets that one at the top, it also has to give its contribution. So sharing is always a two-way street. So now carbon's got 8 electrons around it, and each of the oxygens actually have 8 around it too, by sharing 4 in the middle. So that's another example of a double bond. Again, it could be drawn as follows. You could actually, often it would be drawn as follows. Carbon, just do it entirely in black this time. So carbon with an oxygen. Sometimes these pairs are done off as an angle, like so, and then carbon on this side, alright, with oxygen, and again it's electrons over here. So you can see here oxygen with 6 electrons, this oxygen with 6, a carbon with 4, but when we put them together, this oxygen's now got 8, that oxygen's now got 8, and the carbon in the middle has now got 8 in its valence shell, so they're all stable, they're happy. This is just, it's the same as the diagram before. It doesn't matter whether you take, it really doesn't matter whether you take these electrons here, whether you draw them like that side by side, or whether you draw them as, say, 4 in a row like that. It's really not important. It's the number of them and just showing whether they're shared, whether they're in between the atoms, or whether they're not shared, like the ones out here on the oxygens. So guys, I hope that was helpful, yeah, I think that's pretty much it. I wouldn't expect too many questions in the test with double and triple bonds. It's probably getting a little bit difficult, but we could definitely sneak 1 or 2 questions in there on double and triple bonds. It could in theory come up, and you should be able to essentially deal with it anyway. So it is really a case of, guys, if they can't get a full outer shell by gaining or losing, when a non-metal binds with a non-metal, what happens is they share electrons, and if sharing electrons sometimes isn't quite enough, they can share even more electrons, form a double bond or even a triple bond, are ways that they can form by essentially just sharing even more electrons. So guys, hope that helped, and good luck for your test.